Okay, so in previous lecture we have find the modified Ohm's law, that is current density J is equal to sigma into electric field. Okay, what we find out, that is vector J is equal to sigma into electric field E. Okay, now we have find the expression for electrical conductivity, that is for sigma. Okay, sigma is the electrical conductivity, E is the electric field, and J is the current density. Okay, what is E is equal to V by L. Okay, and J is what? That is J is equal to, that is electric current upon cross sectional area A. So I upon A is the current density. Okay, so now we consider a metal rod. Consider a metal rod. Consider a metal rod of cross sectional area of cross section A. Consider a metal rod of cross section A having the length that is VD. Okay, so here VD is nothing but the drift velocity. Okay, so consider a metal rod of cross section area A having the length VD, that is drift velocity. Let small m, what is m? Is the number of electrons, number of free electron number of free electrons per unit volume. Okay, जो काही रॉड आहे त्याचा व्हॅल्यू असेल त्याच्यात किती नंबर ऑफ फ्री इलेक्ट्रॉन्स आहेत त्याची संख्या म्हणजे n. सो नंबर ऑफ फ्री इलेक्ट्रॉन्स पर युनिट व्हॅल्यूम ऑफ द मेटल. Okay, so therefore volume of the rod, volume of the rod, that is area multiplied by length. The length is VD. So volume that is A into V suffix D. Okay, A into drift velocity VD. At the number of electrons in this volume, so number of electrons in this volume किती होईल? आता काय आहे ते A is the number of electrons per unit volume. आता number of electrons in this volume, total volume मध्ये किती होईल? That is n multiplied by volume of the rod. So this is n A into VD. Okay, this is the number of electrons in this volume is equal to Na into VD. So all these electrons, Na VD, all these electrons NaVd in this volume come out of 1 in 1 second. Due to drift velocity. Okay, so number of electrons in this volume should be Na into Vd, and all these electrons in a Vd in this volume come out at one end in 1 second due to the drift velocity. So R, that is current R, is equal to what? That is number of electrons number of electrons crossing per second, number of electrons crossing into charge on electron. So we get I is equal to what? That is Na into Vd into electronic charge E. Okay, NaVd into E. So therefore, but I write here. So what? From this we can say that I upon A is nothing but M Vd into E. Okay, but I upon A is what? That is current density J. So current density J is equal to NeVd. Ne into Vd. But here Vd is the drift velocity. Okay, and what is the formula of drift velocity? That is electronic mobility of electron, that is mu E is equal to electric field E, that is mu E into E. Okay, so this value put in this equation we get J is equal to N E mu E into E. Okay, and this what? That is and J upon E is equal to Ne into Ve mu E, where J upon E is the what? Electrical conductivity, because that is electric conductivity J is equal to sigma into electric field E. So therefore J upon E is equal to sigma. Okay, so electrical conductivity is equal to Ne mu E. Again mu E is equal to what? That is but mu E is equal to, that is what? Mu E is equal to electronic charge upon, that is collision time. Okay, that is what? Average, that is time between two successive collision. So E into time between two successive collision is tau upon 2n. Okay, so by putting this value we get sigma n E square tau upon twice n. Okay, so this electrical conductivity is can be expressed in terms of mean free path, and mean free path is denoted by lambda. Okay, this is lambda. So this is electric conducting and we express in terms of the mean free path. Okay, what is the formula of mean free path? That is average thermal speed V into time between two successive collision, that is tau. So what is lambda is equal to small v into tau. Okay, where where what is V is the what is V? V is the average thermal speed. V is the average thermal speed of electron in the absence of electric field, and tau is the that is time period of two successive collision. So putting this value, so in this equation we get what, that is tau is equal to what, that is lambda into V. Okay, so put this, so we get, that is why we put in, that is tau is nothing but lambda upon V. Okay, so by putting this value we get that is electric conductivity sigma is equal to n E square upon lambda upon twice mv. Okay. Now the average kinetic energy. Now the average kinetic energy. Now the average kinetic energy. What is the average kinetic? What is the formula? That is half into mv square of an electron. Average kinetic energy of an electron. If you explain, that is 5 by 2 kT. Okay, 5 by 2 kT. Therefore, but we know that there is kinetic energy. So what is the formula of kinetic energy? Half. The average kinetic energy is 3 by 2 kT. And kinetic energy is formula है half mv square. That is equal to 5 by 2 kT. So therefore, V. So what V is equal to what? 2 gets cancelled. Okay, so thrice kT upon m. So V by the under of thrice kT m. Okay, so put this value in this equation, we get sigma is equal to what? N E square lambda upon twice m under root of m upon thrice kT. Okay, so sigma is equal to n E square lambda upon twice m under root of m upon thrice kT. Therefore, this again we can written as what? That is sigma is equal to n E square lambda upon, so this m, so this is under root of this m is cancelled out, so thrice e upon lambda square is equal to twice under root of thrice m kT. Okay, thrice m kT. This is the expression, this is the final expression. This is the expression for the electrical conductivity of the metal on the basis of Drude-Lorentz free electron model. Okay, this is the final expression of electrical conductivity on the metal on the basis of Drude-Lorentz free electron model. Drude-Lorentz free electron model. So this is the final expression, that is sigma, that is electric conductivity is equal to n into E square upon lambda divided by twice under root of thrice m kT. Okay. So for this, what we consider first? Again, I repeat all these. Okay. So what? First we consider the metal rod of cross section area A, having the length Vd. Vd is what? That is the drift velocity. After that we consider the n. N is the what? That is the number of free electrons per unit volume of the metal. So volume of the rod, it should be, that is area, cross section area multiplied by drift velocity, that is A into Vd. So therefore number of electrons in in this volume it should be n into, that is volume is n into a into vd. Okay, so all these electrons, that is NaVd, in this volume will come out one end in 1 second due to the drift velocity. Therefore, so the current through the metal in the net charge crossing the end in 1 second, it should be, that is I is equal to number of electrons crossing into charge on electron, number of crossing in 1 second, that is into charge on electron, that is NaVd into E, that is the charge on electron E. So therefore we get I upon A is equal to NeVd. Therefore I upon A is equal to NVD into E or NeVd. But I upon A is nothing but the current density. So J is equal to NeVd. Therefore, but drift velocity is equal to mu E into electric field. Therefore, J is equal to Ne mu E into E. Therefore, J upon E is nothing but Ne into mu E. But J upon E is the electrical conductivity. So sigma is equal to Ne into mu E. But mu E is nothing but, that is E into tau upon twice n. So therefore, putting this value in this equation, we get sigma is equal to Ne square upon tau upon twice m. Thus, the electrical conductivity can be expressed in the terms of mean free path. Okay, so what is the value of mean free path? Lambda is equal to V into tau, where V is the average. V is the what? That is the average thermal speed of electrons in absence of electric field, and tie is the, that is time period of the two successive collision. Okay, so therefore tie is equal to lambda upon V. Put this value in this equation, we get sigma is equal to Ne square upon lambda upon twice Mv. But we know that the average kinetic energy of electrons should be thrice by 2 kT, and that is the kinetic energy is equal to half mv square is equal to thrice by 2 kT. Therefore, V is nothing but under root of thrice kT by m. So we get, put this value in this equation, we get sigma is equal to Ne square upon lambda upon twice m under root of m upon thrice kT. So this m is cancelled out here, so this here remaining only root m. So therefore sigma is equal to Ne square upon lambda, so twice under root of thrice m kT. This is the expression for electric conductivity of the metal on the basis of Drude-Lorentz free electron model. Okay, thank you.